back. Question 5. Given the complex number z equals 5 plus I on 2 plus 3I, A. Express z in the form x plus yi, where x and y are real constants. B. Show that z is equal to root 2 cos pi on 4 minus I sin pi on 4. C. By equating the form in A to that in B, show that equal to 1 on root 2. Sub 2. The line y equals 3 minus 2x is a tangent to a circle whose center is at the point 3, 2. Find the equation of this circle. Hello viewers, hello fans. Please, if you have not subscribed to this channel, now is the right time to do it, because the next videos on the channel, you might not be able to watch them if you're not subscribed. And guess what? Subscription is free. You don't have to pay anything to subscribe. But if you need this complete paper or from 2015 to date, then you can contact us on WhatsApp to buy in PDF form or make your purchase online so that it can be sent to you in any other means. Please watch this video to the end and don't forget to share in the WhatsApp groups in which you find yourself, and Facebook and all other social media pages. Let's move it. So the complex number z is equal to 5 plus I on 2 plus 3I, and they want us to first of all express it in the form x plus yi. So we are going to do what we call a realization of the denominator. We make the denominator become real, okay, unlike what you saw previously. So what is the conjugate of the complex number 2 plus 3I? The conjugate, or the complex conjugate, is 2 minus 3I. So we will multiply the numerator and the denominator by this 2 minus 3I and simplify. So for the numerator, we're going to have 5 times 2, 10. 5 times minus 3I minus 15I. I times 2 plus 2I. And I times minus 3. That is I times minus 3I. I times I is minus 1. Minus 1 times minus 3 is plus 1. So we have plus 3 at the end here. For the denominator, we can just take 2 times 2, 4, plus 3I times minus 3I, which is equal to plus 9. Okay? So finally, we have 13 into 1 minus I on 13, which is equal to just 1 minus I. So we have written in the form x plus yi. In this case, our x is 1, our y is negative 1. Now the B part of the equation. Show that z is equal to root 2 cos pi on 4 minus I sin pi on 4. Okay? So here, we first of all need the modulus of this complex number. Okay? The modulus or the magnitude. And that's going to be given by the I value squared plus the j value squared. Okay? So for the x, we have that is 1 squared plus minus 1 squared, which is equal to root 2. Okay? Next thing we need is the argument. And the argument of this is arc z is equal to arctan negative 1 on 1. That's the y component on x component, which is equal to negative pi on 4. Okay? So in the form R6a, or z is equal to modulus of z at z, we will have a half into cos negative pi on 4 plus I sin negative pi on 4. Okay? But what is cos negative pi on 4? Note that the cosine function is an even function. Therefore, cos negative pi on 4 is the same as cos pi on 4. On the other hand, the sine function is an odd function. And sine negative pi on 4 will be the same as negative sine pi on 4. Okay? So this is what we have at the end as required. So you're just going to say as required. Okay? Next part now, you see by equating the form in A and the form in B, we should show that cos pi is equal to 1 on root 2. So we equate 1 minus I to root 2 cos pi on 4 minus I sin pi on 4. So when we equate it in C here, what do we obtain? We obtain, if we now expand, we'll have root 2 cos pi on 4 is equal to, on the right hand side, 1. So this therefore implies that cos pi on 4 is equal to 1 on root 2 as required. So if you have everything This is already 9 marks for this question, just for this part. Now, sub 2. In sub 2, we are being told that the line y is equal to 3 minus 2x is a tangent to a circle whose center is at the point 3, 2. Okay? It's a tangent to a circle whose center is at the point 3, 2. Find the equation of the circle. So, if this line is a tangent, it means that if you can find the perpendicular distance from this line to the center of this circle, that will give us the radius of the circle, which we can now use to form the equation of the circle. Again, if this line is a tangent to the circle, if you can find the perpendicular distance from this line to the center of the circle, that is going to give us the radius, as you already know, right? And we can now use that to form the equation of the circle. So y is equal to 3 minus 2x implies 2x plus y minus 3 equals 0. So how do we find the perpendicular distance of a line to a point? So the perpendicular distance of a point from a line is given by d, or in this case the radius, so we're going to call r. R is equal to the absolute value of ax plus by plus c, all that on the square root of the sum of squares of the coefficients of b and of x and y. So this gives us 2 into, note that our x and y here will be the center of the circle, okay? So we have 2 into this, the x value of the center of the circle is 3, plus b. Our b in this question, because we have 2, our a is 2, our b is 1, our c is -3. And then these 3 and 2 in brackets are the values at the center of the circle. So we have 2 into 3, plus we have 1y, so 1 times 2, where 2 is the y value at the center of the circle, minus 3. All this on the root of the squares, the sum of squares of the coefficients, that is x squared plus y squared. Coefficient of x is 2, the square coefficient of 1 is 1, you square it. So this is going to give us 6 plus 2, 8 minus 3, 5 on root 5. So 5 on root 5, that's the radius of the circle. Now, what's the general form of the equation of a circle? The general form of the equation of a circle is given by x minus the value of the x at the center, x minus x0 squared plus y minus y0 squared equals r squared. Our r squared is going to be equal to this value we have here, 5 squared 25 on root 5 squared, which is 5. So we have x minus 3 squared plus y minus 2 squared is equal to 5. Okay, so that has given us 5. Thank you guys so much for watching. The next question is question 6. But before you go, we are in need of chemistry paper 3 questions. A lot of students are asking us. We did not consider this at the beginning. So please, if you have chemistry paper 3 or your friends have them, please use the link below to get to us and send them. We are really begging. Other students sent these ones to us, which we are enjoying. So please help others to get it. Equally, if you need the complete pamphlet or manual for past solutions, please just contact us using the link below. To watch most of our videos or download past questions, equally use the link below. Thank you so much for being there. Love you all and bye-bye.